So I've decided, in a little bit of a break of direction, that I'm going to have a go at using some of the firmware commands. So these are commands that are in part of the ROM that runs the general sort of computer that you see, deals with the inks and everything from BASIC. Looks much closer to the basic commands. Clear screen, set ink, etc. So what I've done is I've copied where we got to last time, and I've replaced all the code with just some firmware calls up to the point where we're going to draw something. I haven't actually drawn anything yet, but we can see that this is now there are just some simple calls that we can make. We can't optimize much of this because most of these commands actually clobber the registers that they pass in, so we can't kind of reuse them from one thing to another. We actually have to set them quite deliberately. We'll end up with an infinite loop that's just actually going to do nothing. It's literally just going to spin, doing nothing. And we're going to draw in here. Now, one of the things I thought about was, instead of having this font table, what I want to do is just use the firmware font and just try that. Now it's bigger, so it's 8 by 8 for each character, but it is encoded in a similar way to how we were encoding it, and so I think actually with a small modification we should actually be able to use it to draw the characters. So just going to give that a go. Now the first thing is that I need to find there is a function. I'm just looking in the firmware guide. I have seen it. There is a function that will actually just get us the text, the font, and I think I saw that will even return it in the DE register, which is nice and convenient for us because that's what we've actually used. Right, so get matrix it's called. Txt get matrix, and actually I was wrong. It actually returns the information in HL. We need to use A to pass in the character whose matrix is to be found. Now, interestingly, what it doesn't tell us is whether those are the sort of ASCII table, where, for example, so if I put 65 into 65, 64, one of those numbers in that range for the upper case, or whether there is another table. So I'll need to just try something there. Let's go for 64, and we're going to call firmware text get matrix. So now HL character matrix. I think we can do that. Just exchange those two, and then we are going to put our character. We're going to just put it in the top thing. So now we have our matrix. I realized too that rotating to the right will mean that the character is reversed. So I think if we go the other way, we will take things from the left hand side of the byte first, and the character matrix should be 8 by 8. So I think that is all that we need to do. Got to actually call draw character, of course. So the next thing to do, that builds. Next thing to do is just to give that a try, see what happens. I have saved it to disk with an F, and we don't get anything. Don't get anything on the screen. Okay, back to the code. So I've done a little bit of research because I haven't used the firmware much, but there was a comment in the description for firmware text get matrix that said that it might return an address in the lower ROM, which makes sense because that ROM encodes the font, and I'm sort of aware then that those ROMs are often enabled or disabled, so that when you actually do a read, you're either reading from RAM or from the ROM. But in order to read from the ROM, you actually have to enable it. So it turns out that there are more firmware calls. KL ROM enable, which is B906, and there is also disable that we can use, B909, we can use afterwards in case we want to use that area of the RAM, because once the ROM is enabled, every read will come from the ROM. If you write, that does go to the RAM because you can't write to the ROM, but every read will return things. So we might want to disable it afterwards. So if we call, I think we can probably just call that somewhere near the beginning, ROM enable, and then once we've drawn our character, let's just call the disable. Right, let's see if that has made any difference. And there we have it. We are actually drawing a character from the system font onto the screen. Now, that probably isn't the character I was expecting. So the next thing to have a look at is actually just to make sure we're mapping to the right character set with the right numbers there, and see if we can actually do a bit more, write a little bit more to the screen. So it turns out that it is actually drawing ASCII. I looked everything up in the manual, and here we are. We actually have ASCII, and I was just wrong with my ASCII numbers. I had A down as 64. I thought it was 65, and then I thought, no, I always get this one wrong, and went the wrong way. So this should now display our A. Brilliant. So I think we're now ready to actually have a go at printing a bunch of characters using the system font. I actually think that looks nicer than the normal the normal A. So this might be, yeah, see there's the normal A. This might actually prove to be a good way to do it. So we'll have a go at printing more than just one character to the screen. So let's define a little let's say hello, and that's going to be message. So what we're going to want to do is we're going to need to loop through that message. We can use like 0 as an end. So we can loop through until we've got a 0. So let's say let's load HL with our message. So that points to the beginning of the text. We are going to have to store. Yeah, we have to store that. We have to load with A with what's an HL. If it's basically 0, then we're going to go to loop because we will have finished. Otherwise, we will get the matrix for that character. That will now be in HL, and we will now need to have HL with our address. So we can do that by getting DE to that. Let's remove the push for a moment. So DE is going to be the screen address for the moment. HL is going to be the pointer to the message. We get the first character, compare it to 0. If it's 0, we get out of there. Otherwise, we get the matrix. That now means that the HL's been clobbered by that point. So yeah, we really should push HL here. Now, when we exchange D and HL will now contain our screen address, except for we also are going to need to push DE, and we're going to need to pop both of those after here. We need to make sure we keep DE in between these. And then we exchange DE and HL. HL will now be pointing to our character. Sorry, DE will now be pointing to our character, and HL will now be pointing to our screen location. So we can now call draw character, and then we can jump back round to, well, we will be able to. Gonna have a thing called finish message, where we're gonna call ROM disable, and then our loop is just going to go back round. Now, what we're going to want to do here, so this is initial setup. We're going to be pushing HL each time through that loop, so we're actually going to pop HL here, because that is our message position. Again, I'm sure there are some easier ways to do this, but we will we're incrementing the message position, but we also need to increment the DE pair, and we're going to have to do that 8 times. I'm going to just do that longhand for the moment. So initial setup, DE points to C0000, HL points to the message. Push HL, get what's okay. This is going to be a problem because we've now done something funky with the stack. We only really want to push HL if we're going to do some stuff here. So we load A with what's at HL. If it's 0, go, finish. Otherwise, push HL, push DE. Now HL contains exchange the two. Now HL contains screen address, DE contains character matrix, and we say we're going to draw a character, but we know that this clobbers DE and HL, so we need to push HL and push DE. Now on the other side of that, what we actually want is them in the opposite order, because we want HL to be no, got this wrong. Don't care about HL there. But but we want to push DE on, and then no, we need to push HL because that's the screen address. Yeah, we want to remember the screen address that we're at. We haven't yet popped that one off, so then when we pop, we take the screen address into DE and the so 1, 2, just going to put the stack depth in each one. 2, then we go 1, 2, 0. We would finish the message, disable, and just go into our infinite loop. Just to double check. DE, screen address, HL, message address, get the character if it's 0, and push the message address, push the screen address, get the matrix for the character, which is A, then we get our screen address back, we exchange the two. Now HL contains the screen address, D contains the character matrix that we got from there. We push the screen address because that's the thing we need to remember, tell it to draw the character, and then we get the screen address back into DE because that's what it was originally in up here, and we get HL back, which was the message position. Then we increment the message position, increment the screen position, and go back around the loop. Make this more explicit as just been checking that. Right, I think it's time to give it a go. There we are. Font, system font. Yeah, those characters don't look quite as good, I must admit, as the A did. That looked quite promising. This looks much more obviously the system font. So anyway, that allows us to display some text. Interestingly, this is a little bit shorter. I'll say shorter. It's longer now, but we're doing a bit more. We are doing more than our last one. So yeah, this interesting idea about whether it's possible or allowable even to use the firmware for an intro. So I've got a couple more things that I just want to fiddle about with and play with on this, and yeah, we'll just see how we go. So one thought I'd had was, okay, this font is it's a bit blocky for us, but maybe we can actually just skip some of it and see what that actually looks like. I probably should have checked in the character in the manuals because it has all the characters in there. I could actually see whether this is a good idea or not, but I'm just going to try it anyway. And so what I'm going to do is say that there are only going to be 4 columns, and we're going to skip a column. I'm just interested to see what that will actually look like. Huh. That is actually surprisingly good. That is really interesting. Who would have thought? Who would have thought? Wow. That's interesting. Right. So we get a potentially a nicer font here. I'm going to reduce the space between them again, and then perhaps see doing a little bit more of an A B C D and see what we get. So we don't need to go as many characters, and I think we can actually display quite a few here, but we probably want to this is let's try that. Yeah, so not all of the characters are going to come out perfectly in that, but a surprising number. It's a surprising number of characters that actually look okay. Well, yeah, that's an interesting little exercise, I think. I don't think we can reduce anything from the height because the font is definitely designed to be at that height. So, but that's yeah. Right, I'm going to try one more, which is interrupt, and just see what happens with that. So that is supposed to be interrupt intro 1, but yeah, that's not really readable. Okay, back to the drawing board on that. I'm gonna, before I finish this, I'm just gonna display interrupt intro 1 using the normal system font, and then I'll call it a day there. So I've made a little modification to display 2 lines of text, and to do that I moved the code that we had to draw the message into its own subroutine. Interestingly, here I can use ret-z to return from the subroutine, and then this just loops around as before, but I can call that multiple times now and set up different messages. So having done that, I have set up 2 message lines, interrupt intro number 1 and is now ready to run in the emulator. And there we are. They're going to stop there for now. Just an exploration of how using the firmware might actually allow us to make something without having to encode the font as a font table, because we can lean on the system one. And because we're drawing it in this particular way, that actually doesn't look too bad. So yeah, I might end up using this. I think we would want to do something to display this in a more interesting style, perhaps animate characters in, or yeah, something like that to make it more interesting. But if we look at the size of this so far, we've done that all in 191 bytes, and that's not particularly optimized. I think there's a lot of room for things there. Obviously, the text takes up quite a bit of space, but there are things we might be able to even do there. Of course, if we want to put music in, that the budget gets eaten up very quickly. But I want to stop there for this, because that's quite a nice point to have got to. So just a brief conclusion. I've changed the approach that I was taking. A bit of an experiment. We might go in a different direction eventually, but this is leaning much more heavily on the firmware to do some of the work for us, to clear the screen, to set the inks. We're not doing all of that ourselves, and we are also using its font tables in order to get the font, which means that we don't have to store a font ourselves. So anyway, hope that's been interesting. As usual, comments, questions, whatever feedback you like, it'd be great to hear from you. Thanks for all the encouragement from people who've already responded, comments in the CPC wiki forums and on YouTube, and the likes and views. So thank you for that, and I hope this keeps being interesting.